Yes.
Okay. Hello, good afternoon, everybody. Thank you very much for attending this webinar in conjunction with Apposite Technologies and Open Reality. I'm just going to do a really quick introduction to Open Reality before I hand over to Kevin and Cade, who are going to take you through Apposite's traffic generation products today. So for those of you who aren't familiar with Open Reality, we were founded back in 1999 as a specialist network performance company. We're still privately owned. More recently, you've probably noticed that we've broadened our portfolio into security and cloud, and we've also got a strong wireless distribution segment of our business now. We've got 2 offices in the UK and 3 data centers. Our HQ is in Abingdon, which is where I'm based, and yeah, we've got a strong technical core to our company, and yeah, 42 employees last count. So in terms of our solution, so as I mentioned, we started off as performance management, and application performance management is still definitely a core piece of our business. We've broadened the portfolio with Bright Cloud, who are our sister company. So Bright Cloud are specialists in data protection, cloud, and end user computing. They also do data center and support services work. More recently, we've been doing a lot of focus on cybersecurity, which Apposite Technologies products actually fit quite nicely into cybersecurity, and the application performance management pieces. There's a dual aspect there. And as I mentioned, we've also got our Wi-Fi distribution business. So we're all about talking to our customers about what their priorities are, what projects have they got, and what problems are they looking to solve. And there's normally something in our portfolio that can help them. If you do have any questions following the session today, here's our contact information. As Apposite's distribution in the UK, we'll be your first port of call for any inquiries or demo requests for the product. As I said, Cade's going to be giving you a demo later anyway, but if you've got any more questions about pricing, or you want to see something in a bit more detail, or you'd like some more information about Apposite's network emulation products, which we're not going to cover in much detail today, then please reach out. We can furnish you with any information that you may need. Okay, that's me done really. I'd like to now hand over to Kevin, who's going to give you a quick overview of the Apposite traffic generation suite before he passes over to Cade for a demo.
Hey, thank you, Sam. As Sam mentioned, my name is Kevin Godwin. I am the liaison to Open Reality from Apposite in regards to sales. Share my screen here. Okay. So a little bit about Apposite Technologies. We're the market leader in network emulation, and we have recently entered the market in traffic generation as well. We were founded in 2005, based in Los Angeles, California, and have over 3,000 customers globally to date. And those customers don't fall into any one vertical. We deal with anyone from a Global 500 and Fortune 1000 to government and military divisions within the US government, the defense in the UK, and the telecom industry as well. How Apposite helps our clients. What we do is we improve end user experience by giving them the ability to see and feel the remote end user before they deploy any type of application or business system over their live network. And specifically to our traffic generation solution, we give you the ability to generate realistic application traffic at scale. And Apposite has done a great job of filling the market void when it comes to usability and affordability with a traffic generation solution. What separates us from the others out there is we have a browser-based UI that is wizard-driven. We have an extensive library of predefined applications, as well as the ability to scale live production traffic up to 1 million clients. And all that is done across our 4 different test applications that you see here in Traffic Engine, App Playback, App Storm, and Session Strike, all of which Cade will go into a little bit further. Our traffic generation solution is available both on a hardware solution in 1 and 10 gig, and in a virtual edition in VM and KVM environments. And that is all I had. Cade, if you wanted to go into the demo.
Sure. Okay. I'm currently logged into our traffic generation product. This one is an N61, which is a one-use server with 2 data ports on it. So it has up to 4 ports on it, 2 of which are for management. One is running an SSH server as well as an HTTP server, which is how I log in and run the device. This is our management port. We then have a console port, which you can get command line access through serial. Very similar to what you would see on an HP switch or a Cisco switch. And then, as I said, we have 2 data ports, port 0 and port 1 are for running data. This is a 1 gig model. We have models all the way up to 100 gig, but this just happens to be the 1 gig that I'll be doing the demo on. The great thing about this device is if you know how to configure the 1 gig, then configuring the 100 gig will be pretty much the same thing, just more bandwidth. So when I go to start creating traffic on my network, I need to reserve the 2 ports I'm going to be using to be sending and receiving the traffic. And I do that by clicking these little sliders right here. The reason why you do this is there might be a situation where there's multiple people using your device and you have multiple ports. So you're going to reserve this. And I happen to be logged in as user named test. So if someone else was to log in, they would see, oh, okay. Test is using port 0 and 1. I'll use ports 2 and 3, and that way you don't step on each other's fingers. As Kevin touched on, we have 4 different apps. The most popular app we have is called Traffic Engine. This is a stateless solution, meaning that we don't carry a live or a payload. We actually carry just kind of random data inside the packets, but we make it look like it's a specific protocol. We take on all the characteristics of a protocol. So if it's HTTP or IMAP or FTP or just simple TCP or UDP traffic, it'll flow through your traffic just fine. And it is a stateless solution. So this is really good for stress testing your network, checking to see how your network's behaving, such as bandwidth. Are you getting the bandwidth you're paying for? Are your devices out there able to handle the amount of traffic you're sending down in? Is specific traffic getting split off and behaving differently? So I might have a situation where I have my HTTP traffic is a lower priority than my VoIP traffic. So my voice calls, my voice over IP might have priority over HTTP traffic. And I want to check that. So I could create voice over IP traffic as well as HTTP traffic. And I can send it down the pipe and we can see that the HTTP takes a lower priority than the voice over IP. Next up we have is our second most popular app is called App Playback. This is where you can use Wireshark or TCP dump or any other type of program or hardware out there that can do PCAP files. And you can load this PCAP file into the application and replay it. And this is a stateful solution, and it carries valid data in the payload. And so I'll give you an example of a reason why someone would want this. We had a company that during COVID was using Zoom meetings, and this company had over 3,000 employees. And every 2 months or so, they would have an all staff meeting where 3,000 people would log in onto Zoom and try and see the meeting. Well, they were seeing as soon as they got to, in the hundreds, that their network wouldn't perform as needed. And they couldn't figure out why the Zoom meetings weren't working. So what we did is we recorded one Zoom call. It was about 15 minutes long. We then loaded it into app playback. We replayed it. We verified that it was working fine. And then we multiplied it. So then we multiplied it by 100. So we made it look like 100 people were using Zoom calls, and that worked fine. But right up when we got around the 500 mark, we started seeing performance degradation in the network. They were able to change their priorities, they were able to change their routes, and they were able to solve that issue. And they did that using app playback, using valid data to flow through their network. So again, app playback is a stateful solution. The next up we have is App Storm. This is a stateful solution again. The easiest way to describe this is a very simple drag and drop kind of configuration where you can choose, okay, I want social media traffic going through my network. I would like some production traffic. I'd like some YouTube traffic. I'd like some N-day attacks or Z-day attacks, or even some DDoS traffic as well. You can just drag and drop it, and we can start then putting the traffic on the network. So this can be used for everyday traffic. It can also be used for different types of attacks. And last up is our session strike. And this is mostly to just gauge how many sessions a server or a network can handle. So for example, if this is HTTP, you wanted to see how many users can hit your website and your web server, and can it handle 1,000 connections at the same time? Can it handle 10,000 connections at the same time? You can use session strike to mimic those scenarios. So this is more of a stress tester on different types of servers. You could be an MSQL server, it could be an HTTP server, and we also have abilities to do that on DNS servers as well. So I'm just going to demo Traffic Engine real quick. This is our most popular app. So I have a Traffic Engine test configured here. I've reserved my 2 ports. And what you're going to see is when we go to configure this, it almost has like a step-by-step wizard here. So we can see I'm currently at port configuration up here. The next step will be a host configuration, then stream configuration, traffic configuration, then a summary, and then you'll be able to start your tests. So this is something we're really proud of. All the other competitors, they don't have it this easy to use. We like to say that you need a PhD to use the other competitors' products. With ours, you do not need a PhD. So I'm going to be doing a port configuration right now. So I'm going to add the 2 ports that I reserved earlier to my testing. And we can see here, port 0 is configured to send to port 1, and port 1 is configured to send to port 0, and we're going to send and receive in both directions. Port 0 will be sending at 700 megabits, and port 1 will be sending at 500 megabits. So moving on, you can see we have 2 different port configurations here. This is port 0 configuration, and this is port 1 configuration. So what I've done is I've gone and I've set this up so that port 0 will look like there are 100 unique IP addresses and MAC addresses sending the traffic. So if I wanted to make this more, I could come in here and use this by CIDR block. or I could just come in and type how many IPs I'd like. So we'll go back to 100, or I can come here, do 128. So it will be using these MAC addresses, and then it'll increment by 1. So the next MAC address would end with D3. And then it's using these IP addresses 10.0.0.2, and the next IP will be 10.0.0.3, and then it'll go all the way up to 10.0.0.130. So that's how many IP addresses and MAC addresses will look like is sending this data. Then on port 1, I only set 32 IP addresses, but you'll notice that the MAC addresses are different here and the IP addresses are different. So they're not the same as up here. So port 1 is sending on the 20.0.0.x network, and port 0 is sending on the 10.0.0.x. So we'll go ahead next. So this is where we can set up our different streams. I'll actually just delete these so I can manually add them and show you guys how to do it. So when I want to add different types of streams of traffic, I could come in here. If I wanted to, I could scroll down and choose all these different protocols that are available already. So we have, DHCP, FTP. There's a bunch of stuff in here. IMAP, IPv6, IPv4, HTTP server. There's lots of different protocols in here, POP3, etc. So I'm going to set up first a very simple TCP stream. So I can actually search through here. It'll find my TCP. I'll choose that. I'll add it, and I'll see it pop up down here. I'll add another stream. We'll do UDP. And I'll add this. So now we'll add some, like, what I'll call it mail. So like email, and I'll use IMAP as my email protocol. I can also add something like web traffic. So I can actually customize my traffic. So I can do let's do HTTP-get. And I will add a HTTP traffic here. And now maybe I want to do an HTTP post. So this will be sending data to the HTTP server. And again, I'm going to add HTTP. So I've added 5 streams really quickly: TCP, UDP, mail, HTTP get, HTTP post. So now I want to customize these streams to have specific traits. You maybe run on specific ports, or in this case, I want these to do HTTP get, and then I want this one to do HTTP post. So if you look at these little squares, think of these as layers on the OSI model. You can configure each layer. So if I were to click on the Ethernet layer, I can configure my different ether types on here. Then I can come up the layer to the IPv4 layer. Here's where I can set my TOS or my DSCP. So these are different priorities. Maybe I can come in here. I want my DSCP value to be CS1 or CS2 or whatever. We do TOS 3 bits as well. So we can change it to whatever you want. You can also change your checksums and other things in there. So I'll update that. Then we can come into our TCP settings. And this is where I can set my port. So maybe I want this to run on source port 1000 and destination port maybe 4000. So I can actually change my source and destination points. I want to send acknowledgement syncs and fins, right? So I just updated my TCP. So again, you can do the same thing with UDP. I can change my ports if I want to. Looks like this one's going to send on 2048 and receive on 2049. So let's set up these HTTPs to do what they want. So I have a HTTP get and I have HTTP posts. So if I click on HTTP here, I can set this to get, update, set this to post, update. So now I have HTTP get setting to do HTTP gets, and HTTP post is doing post. So basically, HTTP get is receiving data and HTTP post is uploading data. So I want these streams to run on all ports. I could set it up to maybe, HTTP get is only going to send on port 0 and HTTP post is only going to set on port 1. So I could set it up like that. But in this demo, I'm just going to click this, which tells it to go in both directions. So we can also start adjusting our inner frame gap and our inner burst gap. And then we can change our frame sizes here. So we can increment, we can go with fixed, we can do random, and we can butterfly. So if I were to choose random and I would to put, 512 to 1500, then these packets are going to be created randomly to be in between 512 and 1500. If I set that to increment, then we're going to start at 512 and we're going to ramp up to 1500 size packets. And then if you do butterfly, this kind of ramps up to 1500, comes back down to 512, and then ramps back up to 1500, and it kind of creates a butterfly wing. For now, we'll just leave it at fixed. I'll just set this to 1000. So again, you could do that on each one of these streams. So coming up next, we have our traffic configuration. So let's make this data look a little bit more realistic to what you would see in the real world. So right now, everything is set to 20%. So 20% get traffic, 20% post traffic, 20% TCP, UDP, and mail. So that's not really what a real network would look like. So maybe your mail would be really low, your HTTP get would be high, your TCP and UDP would be high, and then your post would be really low. So how would I configure that? I could do that by going update traffic protocol. Let's set TCP to be 30. Let's set UDP to be 20. Let's set mail to be 10. And let's put HTTP post to be 5. And then HTTP get would be 35%. So I can configure that. And we'll see the pie chart then change. So HTTP get is the most that will be sent. HTTP post will be the least that'll be sent. And then 10% will be mail, 20% will be UDP, and 30% will be TCP. So that was on port 0. I could come in, I could do the same thing on port 1, have it match whatever I expect. Won't bother doing that for now. So over here, we have this load profile. So what this does is I could say, okay, I want this test to run for 10 minutes and run it 2 times in a row. So this is done in seconds. So 600 seconds would be 10 minutes. 1200 seconds would be 20 minutes. Oops. And as you see, when I set this test duration, I can then see 0 to 600 seconds, and I can ramp up and ramp down my traffic, right? So I can see here that it would take, if I set it like this, it'll be about 30 seconds to get to 128 hosts. And over here, we can ramp it down and we can have it be, let's see, let's scroll it down. 30 seconds to ramp down. So, why would we use this? Well, let's take a scenario where you're in an office and people start arriving at work at 7 a.m. and then by 9:30, everyone's in the office using their computers and doing whatever it is they're doing. So at 7 a.m., the traffic will just start trickling in. As more and more people come in, that traffic is going to ramp up. And then by 9:30, you're kind of at your maximum amount of traffic you're sending. So we can use these ramps up and ramp down to create that type of environment. Okay, so this was kind of the last step that you actually do anything to configure this. And you can see that took 4 steps. We had port configuration, host configuration, stream configuration. And now we're doing traffic configuration. The last step is a summary. This is where you just want to check, make sure everything looks good. So port 0 is set to have 128 hosts, and it's going to increment by 1. And then we can see that port 1 has 32 hosts, going to increment by 1. It's using the IP address of 20.0.0.2. We can then see our load profile. The ramp up is 31 seconds. The ramp down is 32 seconds. Test duration is 600 seconds. Integration iterations is 2, so that means it's going to run twice. And now I can go ahead and start my test. So what it's going to do is it's going to pull up a bunch of statistics. It's going to start us off with the aggregate statistics, and it's going to show us what our send and receive packets are. So we can see port 0 is sending around almost 66,000 packets, and port 1 is sending 45,000 packets. And then we can see the receive. We can see our total gigabit throughput. So we're sending 700 in one direction, 500 in the opposite direction. We can measure latency here. Here's our total packets. And again, all of this is in these speed dials down here. We can see that we're getting almost 700,000 packets per second. We're receiving almost at 500,000 packets per second. And then we're sending at 700 megabits, receiving at 500 megabits. And that was port 0. This is port 1. We also have some graphs down here. These are packets per second. We have our throughput graph. So this is the amount of bandwidth we're taking up. And then we have our jitter graph here. This is measuring latency. It's pretty low. It's less than a millisecond. So then we can also go through, I hit the stop button by accident. Let me start that back up. As the traffic starts to send, we can go to per stream statistics, and we can get the statistics per each one of our strings. So we can have HTTP GET. It tells us what our send and receive is. Our HTTP post, send and receive. So we can actually measure by stream as well. And then once we stop this test, we get what's called the offline analyzer. So this kind of gives us our graphing. We can come and take a look at our report in here. And if we see something we don't like, we can actually highlight, zoom in, and then start to annotate, right? So I can say, hey, you know, this right here looks bad. Take a look at that. And then I can save my graph. You can save it as a PNG, JPEG, or PDF, however you want to save it, and do whatever you want. All your statistics are still located in here. So if you want to come back and check them, you can see your per stream statistics as well as your aggregate statistics. So it'll keep these statistics here. Obviously, the live reports are set to 0. So we're not sending or receiving anything. These are 0, but you can see your total packets over here and the amount of data you've sent. Last up, we have our logs. Let's see which one's ours. I'll just download one of these. So what this is it's a kind of a report. That's not the right one. Let me download a different one. So it gives us 3 different CSV files. So these are comma separated variables, gives us our latency, our packets per second, and our throughput. And then what's more interesting is it gives us a report, right? And this report is customizable. So you can put your company logo here if you want. We just put ours in here for now. And it's going to give you what the test configuration was, and then give you all your port statistics, and then give you your graphing, and then finally your per stream statistics as well. The last thing you'll see in here is this XML configuration. So this is how the test was configured. So if you ever need to run this test again and you don't remember exactly how you had it configured, that's saved here in the XML. So if I were to go back here and create a new traffic engine environment, I could come in, I could import my XML file and then rerun that exact same test that I just ran. So up next, I'm going to show you guys AppStorm. Again, this is our stateful solution. The traffic engine is a stateless solution. So I need to, again, reserve my ports, and then I'm going to come in and start configuring my AppStorm test scenario. So I'm just going to delete all these so we can start from scratch, and I'll show you how easy it is to configure. While I'm doing that, you'll notice that we have the steps again here: step 1, step 2, step 3, step 4, step 5, and then you can start your test. So once you know how to configure one of our apps, it's pretty easy to figure out how to do all the other apps as well. So we're really concentrated on making this user friendly. Okay. Sorry about that. Okay, so this is where, again, I said this is kind of a drag and drop. So I don't have a lot of predefined applications or attacks loaded in here, but we could have hundreds of different types of attacks. So you can test your firewall to see if it recognizes, hey, this is a N-day attack or a Z-day attack or a DDoS attack or a DNS attack. You would have more choices on here. I kind of have the basic, internet package loaded here. So you have your social media, your gaming, and as you see, I can just kind of drag and drop in here. I'm going to put some streaming in here. I'll put some e-commerce in here. I'll put some web conferencing in here, and then I will put some productivity in here. So you can just kind of drag and drop it in there. And as you can see down here, this is all getting added to the pie chart. So if I wanted to configure this even more, make it more customizable, I can double click on this icon and I can see what kind of data it's going to send. So we can see we have Facebook, we have Cracked, we have Flickr, Photolog, Instagram, MySpace, if anyone uses MySpace anymore, Pinterest, Shutterstock, so lots of different social media. Twitter's in here, Waze is in here. We also have different streaming in here. So we have Vimeo, I believe there's Netflix in here. YouTube is in here, Netflix is in here, and I can actually click on this and even customize it even more. So this looks like someone going back and forth on their video, fast forwarding, loading, playing a video, buffering a video. So we have all of those different types of scenarios. Again, that'll be in YouTube and all of these other ones. So I can come in and unclick anyone I don't want. So, Gianna, I don't really use Funny or Die. I don't need in there. F-Film. So I can get rid of some of these that I don't want to use and hit configure and it'll update. So again, here's our shopping cart. So we got Alibaba, Amazon, eBay, etc. in there. Let's see, streaming. So we got Blue Jeans, GoToMeeting, LogMeIn, WebEx, and Zoho. I think we have one for Zoom as well. I must not have it installed in this package. And then we'll look at production. So productivity in here, we have Dropbox, Getty Images, GitHub, Glassdoor, LinkedIn. So there's lots of things in here to choose from. So again, I could come in and I can start changing this up. I can update my traffic profile, say, oh, this is mostly going to be web conference, whatever. And then you can get even more detailed. If I click on one of these pie charts, it'll show me, all the different things I can change in here. So this is LinkedIn, Weebly, Whois, Baldo, Dropbox. So maybe you're a big Dropbox user. So I come in here, I could find my Dropbox and just set that to 100%. And now we see Dropbox will be 100% of my productivity. So, but productivity will be only 20% of the total traffic, but I made it 100% of the productivity traffic. And again, you could do that with social media. I could come in, maybe I want Facebook to be 95% or Instagram to be 60%, Facebook to be 40%. I could do that. So I kind of jumped out of order here. I went from step 1 to step 4. Let me come over to step 2. First, I need to set up my client. So this will look familiar to you guys. So this is how many clients I'm going to have. And each client will have its own IP address and MAC address. So this is currently set up to have 64. I want port 0 to be my client. So we can also do VLAN tagging needed in all of these apps. We can also, maybe I don't want to use these IP addresses. I want to use a DHCP server out there. I can set this to dynamic. And what will happen is this will go out and get 64 valid DHCP addresses. Again, this is a way you can stress test your DHCP server. So be careful in here. I've had customers, set set this to be like, 250,000 IPs, and they try and use the DHCP server and they cause a lot of havoc. So we'll go back to 64 here. So that's how I configure my client side. Now I'm going to configure the server side. I'll have the server be port 1 and I'll configure that. And now we'll come into this additional configuration. So there's some things in here that are pretty important. Do I want to make it look like it's behind a NAT router? Yes or no. I can do 1-to-1, many-to-one. I want to run all of these parallel, not sequentially. So if I click this as sequentially, first it would try Facebook, then it would try Instagram, then it would try YouTube, and then it would try Netflix. But we want all the traffic to run parallel. So this means it's all going to run at once. I can turn off my stateful reply if I want. And then I can crank up my packets per second if I want to, or change my time to live if needed. That's only if you're going on a big WAN. And again, this is our load profile. I can ramp up and ramp down however I want to do. And then next up is we get a summary. And it's going to give us a quick rundown of everything. So here's all the different tracks in our streams. This is our port configuration. This is our additional configuration. And then I can just start running my test. My VPN is not the fastest right now. There it goes. So again, it's going to look very familiar. We're going to start sending traffic through our network here. We'll get all of our statistics up here, our graphing and everything. So sometimes this takes a few seconds to get started, or I am not licensed to use this. I am in my demo lab. Let's stop this. I might be able to fix this on my back end here. Sorry about that. Let's do this. Let's I might not be licensed to use all these tracks. All right, let's see if it lets me run with these tracks. Give it a few seconds to run. There we go. So we're getting a little traffic to start running through. It's not a whole lot. Actually, it's very little traffic because I took most of those streams out, but the traffic will run through. We can come in and take a look at the statistics per graph, per app. So we can see, you know, Amazon cancel orders, Amazon login, all these different things. And these are ramping up too. So it'll take them a little while to populate. Up here, we can see we're not sending much traffic at all right now. Come in and take a look at our throughput graphs, which are pretty low. We're not getting any latency, but you get the idea. And then you can see the statistics per graph, per app. And if I hit stop, we have the offline analyzer again. And again, it's everything the exact same that we saw on Traffic Engine, where I can highlight, zoom in, annotate, you know, and tell people, yeah, hey, look at that. That looks a little strange. And then we could download our logs again. So it's very similar to Traffic Engine as well. And the great thing is, if you know how to configure one of our apps, then all of the others are very easy to do. So if I were to do app playback or session strike, it's very simple to configure if you know how to configure any of the other apps. So do we have any questions on the board? Doesn't look like it. So that is a quick run through on the Netropy Traffic Generator using the Traffic Engine app and the AppStorm app. So that's about all I have to show for now, guys. Kevin, do you have anything else you want to add?
No, the only other thing from my side is most everything that Kate had shown through the demo is automatable through our fully RESTful API.
Correct. Yeah. So anything you saw me configuring and running in there is automatable using our RESTful API. We have sample scripts available for anyone interested. And we also have a Postman library to load as well. So if anyone's interested in taking a look at how to configure via RESTful API, just reach out to us and we can get you some sample scripts and Postman templates.
Fantastic. Thank you very much, Cade. Kevin, could you just give a quick overview on how traffic generation is licensed?
Yes, so the traffic generation on the hardware side is sold by the unit depending on the throughput that's needed. And then each application or feature set is sold individually. So you can purchase one or all four modules and then they're loaded on. The hardware does come with a 1 or 3 year maintenance option. And then the virtual editions are 1 year or 3 year licenses as well.
Fantastic. I'll just ever so quickly share my screen again so that if anybody wants to contact us with pricing inquiries or for more information, there's our phone number as our email address there. This recording will be sent to you following the session today. So thanks everyone for joining. Kevin and Cade, thank you very much for your time and for a very good demonstration of the traffic generation products.
Great. Thank you for your time, Sam.
Thanks, guys. Have a great day.
Cheers. Bye-bye.